of made up of all values of x such that x equals 59. Fancy way. Nothing to it. That's all it means. Okay, are we okay with this assignment? Can we move on? Will you be able to complete this? Yes, no, please.
Yes.
Perfect. That was 1.1. So now our next step is to talk about factoring. So this is a big issue. I would like us to go to our class. Where's our class? I have a handout that I posted for you. And here it is under modules. And we are going to go over some examples. If you need more, you will let me know and we can go directly to the assignment and look at it. So this is under important supplements. And this is the factoring flow chart. Factoring flow chart. This is a tiny little document that I created that should give you everything you need about factoring. Everything. So I'm going to stop sharing. So we start factoring. Polynomials, of course. So we're going to look, I'm sure you've done this many times before. You may remember it or you may not remember it. So this is the time for you to cement your understanding of factoring. We're going to look at 3 different types of polynomials. We're going to start with the easiest one, which is binomial. We're going to move on to trinomial. And we're going to move on to polynomials. And you can say, but what are these? These are special polynomials. So this is 3 or more, 4 or more terms. So this is 2 terms. This is 3 terms. This is 4 plus terms. So we start first with binomials. And then we move on to trinomials, and then we move on to the general case. Okay. So I think I am on page, what page is this? 6. Okay. First, let's take a look at, I wanted to review with you special products for binomials, first of all. Special products. I'm going to list them, and we're going to use them one by one slowly. So the special product, number 1, is a squared minus b squared. We have to remember that this is a plus b times a minus b. And we're going to have examples in a minute. The second one, so this is called the difference of squares. Difference of squares. There are 2 more special products. I will say 3. It's a cubed plus b cubed. The next one is a cubed minus b cubed. And the last one is a squared plus b squared, which is not factorable using integers. So you can say, why are you adding it here? Because I would like you to remember that the sum of squares is not factorable using integers. So this is the sum of squares. So these 2 formulas are slightly more complicated. Let's start slowly with some examples, and then we'll get to these 2 formulas. Okay, so I am given a binomial, so I'm going to share my screen. And I'm going to pick examples, and I'm going to go through the strategy in a minute. And I'm going to pick examples from this document, or we can pick other examples, it doesn't matter. Okay, so as you see, the first step is factoring a binomial. Okay, so I would like to start, let's say, with 4z squared minus 25. 4z squared minus 25. Here is what goes through my mind step by step. You're giving me this and you ask me completely factor. So you gave me this binomial and you are asking me to completely factor it. Here is what goes through my mind. Step number 1. What is it? That's my first thought in my mind. What is it? And I have to immediately answer binomial, because the strategy is different for the others. Then my next step is, my next question in my head is this: greatest common factor? Greatest common factor? Do these two terms have a common factor that I can pull out and make my life easier? No. In this case, the answer is no. 4z squared and 25, no, they do not have anything in common. Here is my next thought. Negative leading coefficient? What is that? What is that? Well, the reason I didn't ask myself, is it in descending order, arranged in descending order, because it already is. But that's a mistake. I want to put it in. What is it? Binomial? And then the next question here, I'm going to say 1a, descending order. I skipped because it wasn't, but I cannot skip this question. So what is it? Binomial. Is it in descending order? What does descending order mean? Descending order. From the powers of the variable, the highest powers of the variable, the next highest, the next highest, the next. In this case, I only have two terms. It's a binomial. Z squared and no z. Yes, it is in descending order already. So I'll say yes. I do not have to rearrange it. It's in descending order. Yes. Greatest common factor? No. Negative leading coefficient? No. This is the leading coefficient. Leading coefficient. The leading coefficient, it's in descending order. The number in front of the first term, the coefficient in front of the first term is the leading coefficient. Is it negative? No. It's not negative, so I don't have to do anything. What if it is negative? Well, I will have to factor it out. So we'll have examples in a minute. There is no. Now, question number 4 that goes through my head. Special product. Special products for binomials. Difference of squares, sum of cubes, difference of cubes, sum of squares. Difference of squares, sum of squares, difference of cubes, sum of cubes. Does any of these apply? Difference of squares, sum of cubes, difference of cubes. Of course, these don't apply. I didn't even explain.
Squares.
It's a difference of squares. Once you say difference of squares, you immediately have to write this. So 4z squared minus 25. Once you said the difference of squares, then you have to write this, which means one with plus and one with minus. What number squared gives me this, or what term, I should say, what term squared gives me this? What term squared gives me this?
One, 5.
You want 5 here? And what about this one?
2z.
Exactly. Excellent. Now, let's say I have doubts. If you have any doubts, it's a blink. 2z times 2z is 4z squared. Positive 10z minus 10z out. Positive 5 times negative 5, negative 25. So, I know it took me 3 minutes to write this, but this should go quickly through your mind. What is it? Binomial. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, yes. Done. Okay? So let's take a look at another example. And then we'll look at the difference of cubes and sum of cubes. What will you say about x squared plus 16? Binomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product?
Yes.
Which one?
A binomial.
It's a binomial, but which special product? Let's take a look.
Sum cube.
Difference of squares, sum of cubes, difference of cubes, sum of squares.
Sum of squares.
Sum of
Yes,
squares.
which is?
Not favorable.
Exactly. Exactly. Good job. Okay, so let's look at x to the 4th minus 81. X to the 4th minus 81. Quickly. I know, as I said, it took me 3 minutes to write those down, but now it's a blink. Binomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, yes or no? Difference of squares, sum of cubes.
No, it's not a special product.
Say it again.
It's not a special product.
It is. It's a difference of squares. So when we say the difference of squares, we have to say this. This times this has to give me x to the 4th. This times this has to give me 81.
Is it x squared and 9?
Exactly. Excellent. Check. It's a blink. This times this, x to the 4th. This times this, negative 9x squared plus 9x squared, goodbye. Positive 9 times negative 9, negative 81. Now, because the requirement is factor completely, we cannot stop. Can I further factor this?
Yes.
Careful.
Oh no.
Now here, can I further factor this?
Yes.
Yes. This has to stay as is. No one can touch it. But I know you're going to say the difference of squares, and you will tell me what it is.
X and 3.
Exactly. Done. Finally, we're done with the binomial, but not before I present to you the sum of cubes and the difference of cubes. These are a little bit more confusing if you want. So the sum and the difference of cubes factor into a binomial times a trinomial. The binomial is always easy. It's a plus b here, or a minus b here. Done. But now we have to understand the pattern for the trinomial. Once you understand it, you will never forget it. So here is the pattern inside the trinomial. This is very easy. It's the same thing without the cubes. This is the same thing, but without the cubes. But now let's construct the trinomial. This squared and this squared. This squared and this squared. And now the middle term. So this is always easy. Whatever you have, you just square it. Whatever you have, and you just square it. Now, this is plus. The sequence of signs is crucial here. If this is plus, of course, the binomial is plus, but the middle term is negative. If this is minus, the binomial follows the same suit, but the trinomial has plus in the middle. Easy to remember. Plus, plus, minus, 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 plus. The middle term is nice. It's just this product, AB. That's it. So first I identify the first piece, which is the binomial. Easy. Just copy this and this with plus, this and this with minus. The trinomial, how do I build that and how do I remember it? This squared, and the middle is always the product. The middle is always the product, but I have to be careful about the sign. Plus, plus, minus, 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 plus. Crucial to remember the sequence of signs. Okay, now let's choose so we can practice this one. So, of course, either C or E, or both. Please choose.
C.
Okay, perfect. So y cubed plus 8. Never, ever, ever skip the first steps. Now we have them quickly, and we can say quickly. Binomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, yes. Of course, a binomial times a trinomial. Can anyone give us the binomial? Something that I raised to the third to get y, and something I raised to the third to get 8.
Two.
Yes?
Is it y
Of
plus
course.
2?
Exactly. Now I know the pattern. Square this and put it here, square this and put it here. Of course with plus. The last term is always plus. So please square this and tell me what to write. Please square this and tell me what to write.
Y squared and 2 squared.
Which is?
4.
Perfect. Multiply these two and tell me what to write. How much? Anyone?
Is it y3?
But when we multiply y by 2, we cannot get y3, right?
2y.
That's it. Done. This is it. Nothing else. Once you understand the pattern, let's also do this 1 over 27 minus x cubed. What is it? Binomial. But it's not in descending order. Now it is. Negative leading coefficient, yes. I have to factor it out. What do I have left in parentheses after I factor out -1?
X cubed plus 1 over 27.
Careful. If I write plus, I'm changing the problem.
Negative.
Yes. Yes, let's check. -1 times x cubed, correct. -1 times -1 over 27, correct. Good. Binomial, descending order, greatest common factor, negative leading coefficient. Now you're going to say this is a difference of cubes. And please tell me if it's a difference of cubes. I have minus, minus, and plus. What do I cube to get x cubed?
X.
Perfect. What do I cube to get 1 over 27? One cubed is 1.
3.
Yes. Please square this and tell me what to write. Please square this and tell me what to write, and then multiply them and tell me what to write in the middle. Don't be confused, because when you multiply these, you should not get a positive number, but remember the sequence of signs. Minus, minus in the binomial, and plus in the trinomial. So again, easy to forget. Plus, plus, minus, 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 plus. Square this to put it here. Square this to put it here. Multiply these two and put it in the middle.